Here we have f of x equals 1/2 x to the third minus 2x. Again, let's start by looking at the graph of the function, which we can quickly see does not have symmetry about the y-axis, but it does have rotational symmetry about the origin, which means if we rotate this graph about the origin half a turn, or 180 degrees, it would remain unchanged. This green half would be where the blue half is, and the blue half would be where the green half is. So because of the symmetry about the origin, we know this function is going to be odd. But algebraically, we would need to verify that negative f of x is equal to f of negative x. And let's go ahead and do that. We want to show that negative f of x is equal to f of negative x. Let's start with f of negative x. F of negative x, we'll substitute negative x for x in our function, so we'd have 1/2 negative x raised to the third minus 2 times negative x. So we'd have, this would be negative 1/2 x cubed. If we have an odd number of negatives, the product will be negative. This is going to be plus 2x. We want to compare this to the opposite of f of x, or negative f of x. So the opposite of f of x, we're going to change the sign of each term on the right side of this function. So we would have negative 1/2 x cubed, and then plus 2x. If we compare these two functions, notice how they're equal. Therefore, we have just verified that negative f of x is equal to f of negative x. Therefore, the function is odd, which we already knew graphically. And there's one more thing to mention here. Because we have a polynomial function, and each term has an odd exponent on the variable, this would be x to the first, this indicates the polynomial function would be odd.